So good evening. We continue the lecture series. So now we discussed IV characteristics of a junction diode. So the graphs drawn between bias voltage and current circuit current of a junction diode are called characteristics of diode. And forward bias characteristics and forward biased characteristics is obtained by plotting a graph between forward bias voltage and circuit current. The circuit used in figure. The milliammeter ME measures the current. The voltmeter V measures the potential difference across the diode. The forward voltage is gradually increases in steps and corresponding milliammeter readings are noted. A graph is then plotted between the voltage and current. Periodically, practically no current flows until the barrier voltage is overcome. So once the external voltage exceeds the barrier potential, the current increases rapidly, approximately exponentially. And this is diode equations. I equal to I naught exponential q by v neta kt minus 1. So it is diode identity factor. And this is the diode current, and the expression for diode current is I equal to I naught e power v minus vt divided by nv minus 1. And the resistance calculations. The reverse bias characteristics contains the reverse voltage is gradually increased in steps, and corresponding micrometer readings are noted and graph then plotted between the voltage current, and with reverse bias the reverse current remains very small over a long range, increasing very slightly with the increasing in bias. And resistance calculations, forward resistance, dynamic resistance, del V divided by del I and ohms, and we know that del V and del I are the incremental voltage and the current values of our characteristics. And static resistance RF is equal to Vf by If, and Vf are voltage and current values of our characteristics. And reverse characteristics, statics resistance VR by IR, and VR IR is voltage and current values are reverse characteristics. And this is diode variants, rectifier diodes, signal diodes, Zener diodes, and varactor diode. And rectifier diodes, these diodes are used for AC to DC conversions over voltage protection. And signal diodes detection the signals in the AM or FM receivers. Zener diode voltage regulation purpose, and diode for variable capacitance, electric turning commonly used in TV receivers. So light emitting diodes display and light sources of fiber optic commonly, and photodiodes light detectors and fiber optic communication. And tunnel diodes and negative resistance for microwave oscillations, gun diode microwave oscillator, Schottky diode high speed logic circuits. And this is a semiconductor diode, and this is a diode variant, and the first one is the visible. And diode numbering, first standard AE, JE, DEC, and this 1N series, and single junction devices such as a PN junction diode, and 2N series 2 junction devices such as transistors. And EIA, Electronic Industry Association, JDEC, Joint Electron Engineering Council. And second standard, in this method devices given the alphanumeric codes, and alphabet has the specific information which tells about the applications material of fabrications. First letter materials A germanium, B silicon, C gallium arsenide, and or component materials that mean cadmium sulfide. And second letter for a device type of function, A diode, B variator, C AF low power transistor, D AF power transistor, E tunnel diode, F HF low power transistor, and L HF power transistor, S switching transistor or thyristor or Dirac, and Y power device, and Z Zener. So the third letter tolerance, A plus or minus 1%, B plus or minus 2%, C plus or minus 5%, and D plus or minus 10%. For example, AC128 zirconium AF low power transistor, BC149 silicon AF low power transistor, and BY114 silicon crystal diode, and BZC6.3 silicon xenoid versus 6.3 volt, and BY127 silicon rectifier diode. Thank you. We discuss on next series.